Hello, everyone. My name is Maxime Rouillet, and I'm a cloud advocate at Microsoft. Serverless is really a story about event-driven applications. Developing those applications are getting easier every day, and I want us to go through this journey together. Let's see what it is and what is new in that space at Microsoft. So let's get started. Before we move forward, we'll need to define what event-driven even means. Also, we'll need to put it into context, and there's quite a few. There's event-driven with Azure Functions, but there's also the context of Kubernetes that we need to talk about. We're going to go through this by explaining what Kubernetes event-driven autoscaling, or I always call it KEDA, as well as how we can use functions with Arc. We're going to finish this session with resources and possible next steps for you to learn more. Events are records of something that has happened, a change in state. They are immutable, they cannot be changed or deleted, and they are ordered in sequence of their creation. Now, interested parties can be notified of these state changes by subscribing to published events. And then, on the information they've chosen of their business logic, they can act on it. The source of an event can be from internal or external inputs. Events can generate from a user or a mouse click or keystroke, and even such as a sensor output. But what is event-driven? The event-driven architecture pattern is a really popular way of making distributed asynchronous pattern, and it's used to produce highly scalable applications. This architecture is made up of loosely coupled single-purpose event processing components that asynchronously receive and process events. So event-driven is just that. It's an architecture pattern, and it uses events to communicate between decoupled services. Event-driven applications are built with a serverless approach that use event-driven functions, event routing services, and API management. We went through the actual definition, but let's get down to what it is and what it really brings to you in your application. First, there's loosely coupled. What does it mean? It removes dependencies on other services. Your single service don't need to know that there are 5 or 10 other services depending on it. It just must do its job. It's highly scalable and distributed. What does that mean? Well, it means that we can handle massive amount of events. You add more instances of your application on multiple machines and even in different regions. It becomes then highly composable because in this scenario, it means that each event handling stands on its own, and your application can accomplish what it must do by building it like block by block, which brings us to an increase in efficiency. Because we can react to an event and triggers in the real time, it means that we can also achieve a faster iterative development by having developers focus on their own blocks. Of course, that kind of application is extremely cost effective. Since we're not pulling from a what's new every time, it means that we can only assign resources when we need them rather than all the time, giving us the ultimate payout, paying only for what you use. There are multiple trends that help motivate event-driven applications. Apps are built less to update data, but delivering results to connected applications. The primary focus is no longer to keep the data consistent for predictable request and response workloads, but to connect hyperscale distributed systems that can be very unpredictable. Finally, consistent databases have a scalability limits, but event stream as data store can pretty much scale infinitely. Many modern applications are rapidly adopting event-driven serverless architectures due to the increased demand for real-time application integration and data movement. Event-driven applications are built with a serverless approach that use event-driven functions, event routing services, and API management. There are a few key services that we can highlight that are the components of event-driven applications. Azure Functions is the event-driven code. Logic Apps provides the workflows that can integrate with hundreds of different systems. Event Grid is an event broker that routes events to interested consumers of the event. API management is the central management of all your API endpoint. And this is just not all-inclusive because there are many other services in the Azure ecosystem that you can use to build your event-driven application. More developers are spending more time writing code that allows them to add huge business impact with serverless. Microsoft offers numerous development tools such as IDE support for VS Code and Visual Studio. Whether it is in Functions or Logic App, we also enable local development, visual debugging capabilities, all which are tools of choice. Now, the good news is that Azure Functions runs everywhere. On Azure, it offers consumption plans and premium plans. Whether you want to scale to 0 or want to have a stronger VMs, we got you covered. On Kubernetes, we enable containers auto-scaling based on events that are happening all around your ecosystem. Finally, with Arc, we can do it on any cloud or even in your own data center with your self-managed Kubernetes. And there's no better way to leverage the serverless advantages than using a fully managed service in the cloud like Azure Functions. But some applications might need to run on disconnected environments or require custom hardware and dependencies. Customers usually take a containerized approach for those scenarios, in which Kubernetes is the de facto industry standard. Managing event-driven aware application in this environment is non-trivial and usually insufficient, as it's only based on the resource uses, such as CPU or memory. And when you run out of those, it's often too late, as your application may already be failing. It may also be as simple as wanting to leverage an existing Kubernetes cluster that you already have. KEDA is a product out of a partnership between Microsoft and Red Hat. KEDA means Kubernetes Event-Driven Autoscaling. And it is an open source component for Kubernetes that provide an event-driven scale for any container workload, enabling containers to scale from 0 to thousands of instances based on event metric, things like the length of an Azure queue or a Kafka stream, and back to 0 again when you're done processing. And since Azure Functions can be containerized, you can now deploy a function app to any Kubernetes cluster, keeping the same scaling behavior you would have on Azure Function Services. KEDA, in a nutshell, will exist within your cluster, and based on your choice of an autoscaler, will monitor the events coming in and adjust your workload accordingly. As more events are coming in, or as queue become larger, KEDA will automatically create more containers to handle the workload surge. Durable function is an advanced feature of Azure Functions. They provide the ability to write long-running orchestrations using a single function while still being able to maintain a global state. Among the many use cases are function chaining, so when you want to run multiple functions in a specific sequence, or what we also call a fan-out and a fan-in, so when you want to do multiple events that you want to process all in parallel and then aggregate the final result and handle that result. Or maybe you just want to run something asynchronously and just have an HTTP poll on it and be able to know the status of that workload. And there are so much more scenarios that we can cover. And today, I'm very happy to announce that available right now in public preview, we have 2 new durable backends. The Netherite provider is powered by Azure Event Hubs and storage technology from Microsoft Research. It supports high throughput workloads. Then there's a Microsoft SQL provider, which allows durable functions to run anywhere, including in non-Azure environment. So let's get configuring SQL durable backends in an environment right now in this demo.
So let's open up an existing project and show you how to set up the SQL Server durable backend. Let's open up our project file. Then we need to ensure that we have the proper package referenced. You don't even need a durable functions package since this will be imported along. Let's go into our host.json file. We have to ensure that we select the right storage provider and it is set to MS SQL, and that we have a proper connection string configured to our desired server. If we want, we can also configure our logs specifically for this new backend as well. Now that our application is configured, we need to set up our SQL Server. Let's start with a blank server and run this quick script to initialize our database. Let's confirm that it exists, and as you can see, it's empty. So let's initialize it for durable functions. Let's head back to our project and start debugging. Alright, so now Azure Functions is warming up. As you can see, our CLI tool just loaded our project. Now, it's finding all the different functions that are available in our project. Although nothing seems to have happened, let's head back to our database and refresh the tables. And voila, we now have all the tables defined, ready to run Dribble functions, as well as some stored procedures that will be required for everything to work properly. Let's start a few orchestrators, and let's just say 100. Then we can head back to our local server and see what we got. And to do this, we'll need to start a new query. So let's write a select star from all of our instances that are available. We've got 100 instances that has been run successfully. It was fast as well. Let's close our development server for now. So that proves that it works on my machine, but we're not shipping my machine. Let's show this in a better environment. Let's switch to Kubernetes. This Docker file is pretty boilerplate with a .NET publish and a release configuration, as well as enabling the console logging to better capture what's happening inside a container. Finally, let's not forget our secret file that will import all of our connection strings, and this time it's targeting a database existing in our cluster. It is not targeting a local server anymore. Now, let's launch our function using this new command from our CLI to deploy our Azure Functions directly to Kubernetes. The only thing we need is to provide a few options and our secret file name. But before we run it, let's actually apply those secrets if you want our app to work successfully. All right, let's make sure the command is okay and let's deploy it. As you can see, the application is currently deploying to Kubernetes. That's amazing. And just like any deployments, it takes just a little bit of time for everything to deploy. Let's wait a few more seconds. The deployment has been successful, and we can see right away that there are different functions available to us outside the cluster. If we run a kube-controlled get deployments, we can see our applications as well as our HTTP endpoint. And if we run kube-control get scaled object, we can see our KEDA scalers that are using SQL Server as a trigger for scaling behaviors. If you want to actually see the configuration of that scaler, we just need to add -o YAML, and we get all the details on that specific trigger. Its connection strings, how we decide if we need to scale more or not, and the type of triggers that we're using as well. So let's invoke again the same orchestrators that we did earlier, but this time with a URL from our Kubernetes cluster. Let's make it 100 again. But before we actually start, let's monitor our pods. And we can do that by running kube-control get pods -w. This will create a watcher for us. Then we can start our orchestrator again, and let's head back quickly to our pod watcher before it finishes, right? And as you can see, Kubernetes is now scaling our containers to handle the load of the 100 orchestrator, all starting at the same time on SQL Server. As much as it's fun watching the container scale, let's check how well we're scaling. For this, let's run kube-control get HPA. HPA stands for Horizontal Pod Autoscaler. And as you can see here, we have our minimum amount of pod, or maximum amount of pods, as well as the current replicas. In our scenario, what we can see is how our autoscaler is reacting to the amount of traffic that we're sending towards SQL Server. Let's run another kube-controlled get pods now. And as you can see, all 10 of our pods are currently running and doing well. And just like that, we've gone through how the SQL Server Dribble backend works, what you'll need to configure it, and how well it runs locally, as well as in a Kubernetes environment. Let's now head back to the slides.
All right, so that demo was great. Now the question is, when would you want to use KEDA? Well, there are multiple scenarios. So whether you want to run functions on premises or in an intelligent edge, it is one of the good scenarios for this as well. So also, when you already have an existing Kubernetes clusters, it is an ideal scenario to leverage your existing investment. If you have resources in different cloud, or you love Azure Functions, but you want to be able to run them everywhere, KEDA helps you out as well. And finally, there's some times where you just want to be able to manage the scale and the compute of your Azure Functions, and you really want full control. Well, KEDA handles that for you. And now I would like to introduce Emin from the Azure Functions team, and it will talk to us about some exciting stuff coming to Azure Application Services.
Perfect. Thanks, Maxime. Now in preview, customers don't have to choose between the productivity of Platform as a Service and the control of Kubernetes, because the same application services can run with either model. The application services are now Azure Arc enabled, which means customers can deploy web apps, functions, API gateways, logic apps, and event grid services on pre-provisioned Kubernetes clusters, taking advantage of features including deployment slots for A/B testing, storage queue triggers, and out-of-the-box connectors from the application services, regardless of where they run. The three key benefits you get from using Azure Application Services are: enable your development teams to accelerate their continuous development and deployment of their applications using purpose-built services. Your organization can now choose between hosting the PaaS services on Azure or on your own Kubernetes if added control is required, or if the application needs to run outside of Azure. And lastly, with Arc, you can now build your applications once and run them anywhere. I'm now going to show you running Azure Functions on Kubernetes with Azure Arc. Let's have a look at the demo. In this demo, I'm going to create a new function app that will host my application. However, I need to have this running on my own data center. So I'll give it a name called Contoso Farms Northwest v3. And I'll select Python and then choose the location to create this application. As you can see, there are new custom locations that are now available to me beyond the standard Azure regions that would normally host my application. I'm then going to walk through all the standard create experiences as if I was deploying this on an Azure region instead of my custom location. So I'll click create, and then this new app will get deployed on my Kubernetes environment that is represented by the custom location, Contoso Farms Northwest. So I'll go to the resource. You can see here that has the same management experience as if it was in Azure. So I have a consistent way of managing applications, no matter where they run. If I click into the URL of the application, you can see that the function app is running on a Kubernetes environment. I'll then switch over to create a function using VS Code and deploy to this application. If I look at my subscription, you can see that the new function app I just created running on Kubernetes is available within VS Code. I'm not going to create the code and deploy to this application. I'll select Python and a simple HTTP trigger and give it the name process device. This will create all of the code required to fully test this locally, as well as make it deployable on the Kubernetes environment. So if I set a breakpoint and then debug the application, I can test that it is working correctly locally within VS Code before I publish it. You can see it hit the breakpoint that allows me to inspect the values and confirm that is working correctly. I'll now publish this up to the function app I just created that is running on the Kubernetes environment. I'll zip up the project and then use the same AZ function app commands that I would use if running on Azure to publish the code. This gives the same development experience whether developing for Azure or on a Kubernetes cluster. So that published successfully. Now I can hit the same HTTP trigger that I tested locally up on the function app in Kubernetes and confirm things look good. I'll now show how all this is made possible. I'm now back in the portal, and I'll go down to the Contoso Farms Southwest Resource Group. You can see that I have a Kubernetes cluster that is registered with Arc, so I can manage it from Azure. Arc-enabled clusters have the extensions capability to enable services on Kubernetes to be deployed. I have deployed our application services, including web apps, logic apps, and functions in the Microsoft.web.appservice extension onto the cluster. Now that the services are deployed, I can create a custom location to map to this cluster. You can see that Southwest Farms is enabled as an Arc-enabled service. And it maps to the cluster that we just registered. If I go back to create a function app, you can see the custom location that we just reviewed is now available. This enables a consistent developer experience, whether building and running your apps on Azure or on Kubernetes. If you'd like to learn more about the topics we covered today, please visit the KEDA site or the new site on using durable backends, or read the blog announcing our Azure application services on Azure Arc.
Thank you so much, Hammond, for the demos. And I hope that you all enjoyed them as much as I enjoyed them. And we hope that you have an amazing build, and we hope to see you soon.